Now that we know that logarithms are just exponents, let's look at some of their properties. Starting with the change of base formula. Let's let a, b, and x be positive real numbers such that a is not equal to 1 and b is not equal to 1. All right, so positive means they're not 0, they're not negative, and now also they can't be 1. When this situation happens, then log base a of x can be converted to a different base using one of these three techniques. We could go to any general base b by taking log base a of x and rewriting it as a ratio, log base b of x over log base b of a. In fact, the name logarithm is it comes from a ratio of values, so this is one of the best ways of rewriting a logarithm. Notice that the base, is already written a little bit lower, so it's the one that goes in the denominator, basement denominator. But I don't know why you'd want to convert it to base b in general. That's ridiculous. I prefer to convert it to base 10 so that I can use my calculator. So if I have log base a of x, I can evaluate that on my calculator by entering log of x divided by log of a. Or we could use the base of e, the natural logarithmic base. Log base a of x is the natural log of x over the natural log of a. You'll absolutely want to keep these in mind as you're doing your decimal approximations. The TI-84 can enter the log base a of x, some value, not with variables. If you use your math menu, the third button down on the left hand side, you want to arrow down until it says log base, and then you could enter a value and it will use the change of base formula. If your calculator is not that fancy, you'll want to use one of these two ratios in order to evaluate the logarithms we'll have in the next section. Some properties of logarithms. Let a be a positive number such that a is not equal to 1, and let n be any real number. So it could be positive, it could be negative, it could be ugly, it doesn't matter. If u and v are positive real numbers, then the following properties are true. Now, everything that's true with a base of a is also true with our natural logarithm. It just has a special notation, so we'll write it a second time. The product property, and keep these names in mind. I'll be using product, quotient, and power as I step through our examples. So the product property says that if you're multiplying two things with the same base, you add their exponents. All a log is an exponent. So log base a of u times v is equal to log base a of u plus log base a of v. Similarly with the natural log. The quotient property says if we're dividing two quantities, right, dividing two things with exponents, same base, you're going to subtract the exponents. All a log is an exponent. So log base a of u over v is equal to log base a of u minus log base a of v. Notice the one from the denominator has the negative. These are just exponents, so it's like saying a negative exponent moves to the denominator. The power property, log base a of u to the n power. So repeated addition or, repeated, oh my goodness, I just messed that up. That's right, we're going to keep going. Repeated multiplication, right? A power raised to a power, what do? We multiply the exponent. Wow, that was rough. But log base a of u to the n equals n times log base a of u, and of course the corresponding rules with the natural log. Let's use some of these and see what exactly I'm talking about. First of all, let's rewrite the logarithm as a ratio of common logs and natural logs. So we're using our first table up here, change of base formula. Using the change of base formula, we could rewrite log base 2/5 of x as either log of x over log of 2/5 or natural log of x over natural log of 2/5. The common log is the log base 10. Natural log is ln in place of log base of e, ln. Notice the 2/5 is the base, it's what's in the denominator. The x kind of on the same line as the log, so log of x goes in the numerator, log of 2/5 goes in the denominator. Using the table again, log base x of 7/8. Notice the extensive use of parentheses. Log base x of 7/8 is log of 7/8, and then I'm going to close the parenthesis before I divide by the log of x. And we'll see this on the calculator a couple of times as well. So make sure you close off those parentheses as you're using your calculators to make approximations here. All right, so now Let's evaluate the logarithm. Using the change of base formula, round your result to 3 decimal places. Instead of having variables, now we have actual numbers. Log of 3/8, log base 3/8 of 9. We can rewrite that as the log of 9 divided by the log of 3/8. In your calculator, there will be parentheses put around this 9. At least to open it up. Make sure you close the parenthesis around the 9 here before you divide by the log of 3/8. Similarly, when you press natural log, generally a parenthesis comes up. Make sure after you type the 9, close the parenthesis before you divide, and make sure you get this answer, negative 2.240, before you go on. Pause, play with it a minute, make sure you can get this value on your calculator. Log base 12 of 3.5, remember this is saying what power do I put on 12 in order to get 3.5? Well, I know that 3.5 is smaller than 12, so the power should be definitely less than 1. Let's see, log base 12 of 3.5 is the same as log of 3.5 divided by log of 12. Or we could use the natural logs. You don't have to use both. Choose one. I just show both so you can see that they are the same thing. It's 0.504, which makes sense. Square root of 12 must be between 3 and 4 because 12 is between 9 and 16. So,